Hi everyone, Dragonfly Rising's School of Data proudly presents the AI Demystified for Executives podcast. This is the podcast for executives who want to learn how to apply AI to their business. I'm your host, Andrew Saltis. As a reminder, this podcast is split into two parts. 7-minute Mondays, perfect for catching up on the week's most important aha moments during your commute or while sipping your morning coffee or tea. And then 30 to 40-minute deep dives into the week's topics on Wednesday. That may be a bit much if you're driving. Be sure to subscribe to this podcast on your favorite platform where you listen to others. You can also subscribe to my newsletter so you never miss an update. The address is in the show notes. Without further ado, let's dive into this episode. This week's topic is an introduction to neural networks and why you should care. This is our Wednesday deep dive episode. Have you ever wondered how your bank detects fraudulent transactions or how Tesla's autopilot works? Neural networks are at the heart of it. AI is becoming a strategic priority. Understanding these concepts is essential for executives making key decisions around technology investment. We see neural networks being used in chatbots, voice assistants, financial forecasting, personalized marketing campaigns. If you remember from our Monday episode, we're going to quickly recap. You could think of neural networks like your brain's neuron. Each neuron, or a node, processes some bit of information and sends it to the next set of neurons. We use the example of trying to predict home price based on house size. So if we had the size and we want to predict the price, you could think about that prediction function like the forecast function you may use in Excel. So we have the input, X, the size, and we're going to have some function that we write to predict the output. That function that you write, that would be considered the neuron in this neural network. We could take that simple one node, one neuron network, and then we start to stack them. These neural networks are composed of several layers. Even this simple example, the size of the house, is considered the input layer. The function that we have trying to do this prediction, that's considered the hidden layer. And then the output, the price, is considered the output layer. So even in our simple example, we have the input layer as the size, we have the hidden layer as our function, and then we have the output layer, the price. And then as we stack these, we have the same thing, except you'll have many more hidden layers. So you have the input, hidden layers, and the output. If you've used an image search at all, Google Lens, Shutterstock, iStock Photo, or other tools that do image recognition, or even searching for images when you put in text. When you think about this is being solved with a neural network. So you could think about the image, if we're doing find images like this, or tell me recognize this image. When that comes in, and that image is the input, that is an array of pixel values. So think about this list of pixel values, every pixel in the image. And then these are learned features in the first layer. Okay, so that's the first hidden layer that it looks for the presence or say absence of edges at maybe particular orientations or locations. The result of that will get passed to the second layer. This may typically detect motifs by spotting particular arrangements of edges, regardless of small variations in the edge position. And then it go to a third layer. This may assemble those motifs into a larger combinations that correspond to parts of familiar objects. Subsequent layers, as you continue on, would detect objects as combinations of these parts. Okay, and then the key aspects of deep learning is that these layers of features that aren't designed by human engineers. These are learned from the data using general purpose learning procedures. If you ever use it to do a search or identify something, or using the application to identify a plant, this is how they're working. More complex than our example, but it's all the pixels of the image. And so you start from that most fine grain, lowest level, and then each layer builds upon that until at the end, the output would be that it's a cat or it's a tulip. So there's these key components that are here of these layers: the input data collection, the hidden layer, doing the processing and decision making, if you will, and then the output layer being that final result. You may be thinking, okay, there's got to be more to this. And you're probably going to hear, if you haven't already, of weights and biases. And if you see things that come out about different open source models, so the weights, you could think about these as like volume knobs, if you will. Kind of controlling like how much influence each piece of data has on the final decision. Activation function is another key component. So in this case, like the neuron decides, if you will, when to wake up if this data is strong enough to pass a threshold. So you could imagine if it's in our image example and we're going through that, maybe that second layer that's detecting motifs by looking at particular arrangements of edges, maybe there wasn't a strong enough weight for that, so it doesn't activate the next neuron in line. Okay. And when we think about how this works and how the data moves, there's a couple of different ways to keep in mind. One is called forward propagation. And this is you're trying to guess a password. You input a guess, see if it works. And you move forward if it does. So it works like that, where the data is just going forward through. In our image example, it's just going from the input all the way to the output, just one way. Another process is back propagation. So if it doesn't work, you adjust the guess. So if it's trying to guess a password, if we don't get it right, then we tweak the password and we try again. And then we tweak it again and we keep tweaking it and keep trying. And so this adjustment is the model learning. So you have this forward propagation, one way only, back propagation, where the model is adjusting and learning, kind of tweaking things. So again, there's three layers: the input, which is our data, the hidden layers, which is the inside of the model, if you will, and the output, the result. How this could be used in your particular industry. How can you see this working in your organization? Let's think about the role of neural networks in modern AI. You'll see it being used in all different scenarios and applications across various industries. From computer vision, so you could think about in retail of inventory management. There's been work done of looking at shelves and understanding inventory. In healthcare, for diagnostics, when you hear of models and machine learning or AI that are able to look at radiographic images and come up with decisions as far as, does a tumor exist, does a tumor not exist? That's using a neural network. Self-driving cars. You think of the input being what the camera is seeing and all the steps that you'd have to go through to determine that's a stop sign, or that's a pedestrian, or there's a car. Natural language processing. This has become super popular with the advent of Chat GPT, but is powering customer service chatbots or virtual assistants like Alexa or Siri that have been around long before Chat GPT. These are being used to improve customer engagement and cut cost. Speech recognition. They're being used to convert voice to text, and how businesses can integrate this into call centers and mobile apps. So if you use any speech to text technology, that speech recognition is using neural networks. I record this podcast with software that does voice recognition, produces a transcript based upon my voice. Generative AI. So ChatGPT, DALL-E, these are examples of generative models where they create content. Businesses are using these for creating marketing collateral, various types of content generation, often brainstorming. Let's now look at two more specific examples. Customer experience, personalization, in predictive maintenance. Deep learning algorithms really enable businesses to offer very highly personalized recommendations and services, much like an Amazon or Netflix, able to predict customer needs and behaviors. With that, you could improve retention. You could improve sales. So chatbots and virtual assistants are really driven by deep learning to enhance the service provided. Of course, they provide 24/7 support, could resolve issues quickly. But you could think about, can you use these to help in a speech to text or in a conversation with a customer to determine how to route them? So you could think about using this for a call center and customer service to be able to understand the tone of the conversation with a customer as they're interacting with an automated system, and then route the call to the appropriate person. So if a customer is becoming very upset, you can route the call to a manager. That identification of speech and understanding how the person is interacting and if they're getting agitated could be done by a neural network. You've probably heard of predictive maintenance in manufacturing. These automated processes of doing predictive maintenance with neural networks become much more powerful. In the past, we've had predictive maintenance using the power of machine learning to detect anomalies. Some of these existing systems analyze time series data from Internet of Things sensors. And time series data really just being data that has a timestamp on it. So you think about an IoT sensor that is emitting out temperature or vibration every 2 seconds. A lot of these predictive maintenance systems would look at those time series data sets, temperature, vibration, to detect anomalies or make forecasts on the remaining useful life of a component. And if there are anomalies detected, to be able to schedule maintenance or alert someone for maintenance. When you put deep learning into these solutions, now this has the capacity to analyze very large amounts of high dimensional data. Taking this to a new level, you think of high dimensional data being things like images or audio. By layering in this additional data, audio and image data from other sensors, including very cheap ones such as microphones and cameras. Neural networks now can enhance and possibly replace the more traditional methods. AI's ability to predict failures and allow planned interventions can be used to reduce downtime and operating cost while improving production yield. So a huge way that you could see neural networks really having an impact. If you think about where in your business can you use this, maybe you do have a scenario that is predictive maintenance. Maybe you don't operate any machinery at all or manufacturing. You don't have a need for that. Do you have text data? Do you have time series data that you could mix with audio data or perhaps image data? In the customer service example that I gave of a call center where you're interacting with a voice system and a customer is getting frustrated, you could use voice. You could have the customer history and everything about the customer to then make better decisions as to how to route them and how to provide the best service for them. So I'd suggest thinking about where in your enterprise you could start to think about use cases that you can use this and where this could have a significant impact. As we take a step deeper into the neural network architectures and really just touching on the key architectures here, there's a lot of variety and there's a lot of different network architectures that are out there. We're just going to touch on the four main ones that you're likely to hear about and certainly be looking at using. The first is called feedforward networks. So these are great for basic prediction tasks, such as demand forecasting, where it's really just looking at forward and predicting something in the future. Demand forecasting. Convolutional neural networks, you'll see these abbreviated as CNNs. These are fantastic for image recognition. So the image search we're talking about. You could think about using this in retail, using this in healthcare, in manufacturing, like the predictive maintenance. These could help identify defects in products during quality checks. So it may not be predictive maintenance, but if you receive physical goods and say you are in the retail space and there's physical goods that you receive, can you look at those goods, have a camera look at the goods, and have a convolutional neural network solution be looking at the images to determine whether or not they're defective as you're receiving them? And there's recurrent neural networks. These are abbreviated as RNNs. These are used for time series forecasting, like stock prices and speech recognition. They work best with data that is recurrent in a series. When you think about stock prices, you're looking at the stock value over all different periods of time. So that would be time series forecasting. When you think about speech, it's happening over time. So these networks work with that temporal notion of time to be able to make predictions. Transformers, these have become very popular with GPT, with ChatGPT. Large language models are built on transformers. This is what's powering conversational AI. These do a fantastic job at transforming language, being able to go from English to Chinese. You're transforming one thing to another. Okay, so these are the 4 common architectures that you'll find across the different solutions that you're working with, and to keep them in mind as you're thinking about solutions in your industry and how you make technology decisions and decide on what you're going to use. Right, so there's the feed forward, good for basic prediction tasks, demand forecasting. Convolutional neural networks really excel in the image recognition. Recurrent neural networks, think about time series, stock prices, speech, things that are recurring. And then transformers, being able to transform from one to the other. GPT, generative pre-trained transformers. Okay, so give some thought, and I challenge you to think about how each of these architectures may be applicable to a part of your business. Is there something that you could use, or one of these that you could think of using to enhance your business? Maybe that is automating a process. Maybe it is making a process more effective. Maybe it is a new product entirely based upon data that you have. Maybe you have a lot of image data, and there's a way that you could offer a product that uses that data to do recognition. May very well just be that using conversational AI could enhance your business. Now, these are not without their challenges and limitations, and we touched on this very briefly in the Monday episode. But there's definitely pain points that you'll need to anticipate when you think about ChatGPT, when you think about the competitive conversational AI solutions on the market from Google, from Microsoft, from Anthropic. These are trained on the internet. They need a tremendous amount of data. So if you think of autonomous vehicles, they need millions of labeled images to be able to function safely. And a labeled image is nothing more than saying, this is a picture of a stop sign, and you put a text label of it's a stop sign. On it's seen this size equals this price. We're labeling what the images are as you're feeding the model data to train it. The computational power and cost. It's fantastic that all the cloud providers offer solutions and make it extremely easy for all of us. But really heavy AI workloads can drive up the cost. So it's important that you are cognizant of that and really look to the ROI of what are you getting for these AI workloads. I really strongly encourage you to make sure you're tracking that and you can map that back. It probably won't come as a surprise when you think about these hidden layers that there's really a lack of transparency in how this works. There's a whole set of technologies, whole part of the industry focused on AI explainability. And this is really a key governance challenge, especially in regulated industries like finance and healthcare, where you have to justify all decisions that the model is making. So that's considered explainability. So you need to think about that. Bias and fairness. biased data as the input leads to biased AI systems. This could harm both the brand and customer trust. There are lots of examples and stories recently of biased hiring algorithms. I was speaking with someone last week that had mentioned that they had a hiring system using AI technologies, and it kept rejecting candidates that seemed qualified. The CEO then went and applied and was also rejected. So you need to be conscious of the data that it's trained on, because biased data could lead to biased AI systems. In most applications, this can require a tremendous amount of labeled training data, along with sufficient computing infrastructure to be able to train it. Now, as the size of the training data set increases, the performance of traditional techniques really starts to tend to plateau in many cases. On the other side, the performance of advanced AI techniques using deep neural networks, configured and trained effectively, it tends to increase with data. So these deep learning techniques are really powerful in extracting patterns from complex, multi-dimensional data types, such as images, video, and audio or speech. You got to make sure, though, that the data is collected in a way that addresses everyone's concerns about privacy. So it's really important just to think through some of the ethical challenges, right? Data hungry, perhaps you're not going to train a model to use images, and you may use one of the models that's readily available. Black box in nature, need to think through of how do you tackle AI explainability? And we will go into that in a separate episode. And the bias and fairness, again, make sure that you're aware of the data that the model is being trained with. So think about, how are you prepared to handle these in your organization? And AI really is a strategic imperative. You really need to start thinking about acting proactively and adopting some of these technologies. Please make sure, though, that they're aligned with your business goals. I'm sure you don't need another R&D project. It's very important to align these with goals and make sure that these projects are undertaken in alignment with your business goals. I would really encourage you to look at them as enhancing employee productivity rather than replacing workers. Can you make them more productive? You have to focus on the governance. It's really important to think about fairness, about transparency, and the ethical AI use. And AI is not just about efficiency. It's really about future-proofing your business in a very competitive world. I mentioned on the Monday episode that if you tuned in and stayed to the end of the Wednesday, you'd find out about a free PDF guide that I'm preparing for you. You'll find the address for the PDF guide on neural networks in the show notes below. Remember to tune in Monday. We'll be back for another episode of 7-Minute Monday Quick Bites. If you have any comments or questions, please leave them below or contact me. That's all for now.